So friction, there are two types of friction. There's static and kinetic. Static is the kind of friction that is required to get something going. Kinetic is the friction required to keep it going. So static is required to get it going. So static is when the velocity is 0, so it's not moving yet. And kinetic is once it is moving, okay, the required force to keep it going. It's generally an opposing force, so usually it's labeled negative on the free body diagram. Coefficients are unitless, so there's no unit for the coefficient. Friction itself has a unit of Newton, but the coefficient is unitless. Generally, they're not greater than 1. 1 is pretty rough, and anything above that is extremely rough. The mathematical representation for this, so you have two types. You have static friction. Remember, we usually denote friction with the lowercase f. That's equal to mu times the normal. And the kinetic friction is the kinetic coefficient times the normal. Static friction and for kinetic friction, the unit is going to be a Newton. But for the coefficients, these are the coefficients, mu s and mu k. These are unitless. They have numbers, but they have no unit. And n is normal. Recall the normal is usually equal to the weight, and that depends on the weight, and the unit for that is Newton. So here's a table. These are only for reference. If I give you a problem and you're supposed to find the coefficient, then you're supposed to find it, not look it up. You're supposed to calculate it. Okay, every problem is going to be different. However, let's point out some things. As you take a moment to notice these, you're going to notice this column is the static coefficient, and this one is for the kinetic coefficient of friction. You'll notice that in general, that the static coefficient is going to be greater than or equal to the kinetic. Or in other words, you'll notice that the static friction in general will be greater than the kinetic friction. What this means is you have to overcome friction, right? So for example, let's say the car runs out of gas and your pop says, hey, mijo, get out, go push the car, right? Okay, so they put it in neutral and then they send you to the back of the car and you start pushing. At first, it's harder to push because you're overcoming static friction. But once you get the car rolling, it doesn't take that much force to keep it going. When you get close to a traffic light and it turns yellow and then red, and then your dad applies the brakes, you kind of get a little frustrated because you know it's going to require more force to get it going than it does to keep it going.
Again, please.
The reason for that is you need more force to overcome the static friction. And once you do, and the object begins to be in motion, then it requires less force to keep it going. And that's kinetic friction. Notice also that the coefficients are a physical property between two materials or surfaces. It's not just one. There can't be friction if there's only one object. It's the interaction, right? The action-reaction pair, if you will, between two materials. That's the coefficient of friction. So friction then, the force of friction, depends on two things. It depends on the weight or the normal force of the object, and it also depends on the coefficient, which is a property of materials. Here we have a graph. Is actually, if you understand this graph, it'll be very useful to you, and you'll understand this. Okay. Let's storify this, if you will. So, for example, pushing a car over, we're riding a bicycle, right? We stop at the light, it's red, and if you haven't ridden a bike, you've noticed people riding a bike. It usually takes them a lot more to go ahead and get the bike going, right? And then once they do, it doesn't take as much to keep it going. So the idea here is that you have right here this dotted line here. This is a threshold. This is a threshold that we have to meet before it moves. So if I'm only giving it this much force, it's not going to move. If I'm giving it this much force, it's not going to move. This is the static region, meaning that the velocity is 0. It's not moving. You begin to push a piano, and if you push and it's not enough, it's not going to go anywhere because you haven't met this threshold yet. However, if I go ahead and get a couple of buddies to help me out, I will be able to get past that threshold. And once I do, you'll actually go ahead and experience this. You'll feel it too. When you start pushing the piano, it'll kind of give, if you will. Think of any heavy thing that you've ever moved. It gives, and then you just kind of keep it going. It's easier to keep it going than it is to get it going. This region right here, it's moving, right? And at this point right here is when acceleration happened, because it was at rest and now it's actually moving. So it changes speed from 0 to something. And this is the minimum force required to keep it going. Because anytime you move anything heavy, that if you kind of stop giving it what it needs, it just stops, and you gotta go ahead and start from the beginning. This is the minimum force required. Take a moment to summarize. Explain the difference between static and kinetic friction, and explain the difference between friction and a coefficient of friction. We'll do a quick review here. Problem 1. Calculate the following. A 10-kilogram mass is accelerated by a force of 50 newtons. What is its acceleration? So we have F equals m times a. I want the a by itself, so divide both sides by m. Acceleration is force over mass. So if I do 50, let me do this up here. If I do 50 kilogram meter per second squared over 10 kilograms, you'll notice that the kilograms cancel out, and it leaves me with 5 meters per second squared, which is the correct unit for acceleration. Part B, we are given this time a 98 Newton object. This is a weight. How do you get mass from a weight? You divide it by 9.8, which is gravity of the Earth, and you're going to get the mass. So if I divide this by 9.8 meters per second squared, I'm going to go ahead and get 10 kilograms. Setting up the math and doing everything again, you'll notice that part B is exactly the same as part A once we have found that the mass is 10 kilograms. For part C, how much force is required to move a 10 Newton object that has a 0.4 coefficient of static with a table? So remember, this is expressed by, this is static, so it's Fs is equal to mu s times the normal. So the mu is 0.4. Notice it has no units. The normal is going to be the same as the weight. The weight is 10, and then by Newton's third law, every action has an opposite and equal reaction. Then if the weight's 10, then the normal is 10. Multiplying those two, we get that the answer is 4 newtons. For part D, you better remember this one. If we kick a ball with 50 newtons, the ball will kick back with 50 newtons according to Newton's third law. Opposite and equal reaction.